are going to look at polynomial division. But before we do that, I want to look at what happens with division with integers. Starting with 3 divided by 2, we would write this as 3 with the division bracket and 2. And then we would look at numbers that we can multiply by 2 that would get us close to 1. The number 1 would be our first closest. 1 times 2 is 2. And then we subtract this, and we have a difference here. We would then look to see if this number divides into here. If it does not, this becomes the numerator of a fraction with this number as the denominator, and this would be our quotient. Keeping this in mind, we are going to move into polynomials and look at taking a polynomial and dividing by another polynomial, and we find that the result, the quotient, is another polynomial, so this is closed under division. If we start with something like this, where we have the polynomial, the division, and then the polynomial, or if we start with a rational fraction, where we have a polynomial, and then the fraction bar and the polynomial, we want to rewrite it in this style with the division bracket. So that's going to be our first step here. And since we don't know multiplication facts about what this times some number is that's going to give us polynomials like this, we have a technique for finding the terms that we need. We will take the first term from the inside polynomial, and we will divide it by the first term of the outside polynomial. We're creating these ratios. And we're going to take this term, whatever this reduced ratio term is, and multiply it by the number that we are dividing by. We multiply this out, and this will give us the term we're going to subtract from this polynomial. Now this is the part where we have to use some caution. This is polynomial subtraction. I want to do this two ways. First, I want to show the polynomial subtraction off to the side, and then I want to talk about how that works with the division process. Our setup will be this polynomial, which is the inside polynomial here, subtracting the polynomial that we just created here. When we go to subtract polynomials, we basically are distributing this negative across these terms. So we end up with x squared plus 5x minus 14 minus x squared plus 2x. Notice this piece here is this here with sign changes in every position. We will now gather our like terms. This and this cancel with each other. We have 5 plus 2 is 7x, and then negative 14. So this polynomial is the result of subtracting these polynomials. When we come over here to subtract here, we want to change all the signs here when we put them in here because of this distributed negative sign. This is where I think most students are going to have the problems with all these sign changes. So, at this point, we are doing what we did here. We're gathering the like terms. We're simplifying this. These terms are going to 0. We end up with 7x, and we're subtracting 14. This is what we got over here. Now, if this term can divide into here, we continue the process. If this term will not divide into here, that will be our remainder, just like in our elementary example. I haven't mentioned what happens with the quotient yet. What should go up here? Well, what did we multiply by this to get this? We multiplied this x. So part of our quotient is this x. That was this term here, the reduced common ratio. We're going to do something similar again. We're taking the first term here from our difference, and we're going to create a ratio with the first term out here, and that simplifies to 7, and we continue this process. We take this and multiply it by the term that we're dividing by, and that gives us 7x minus 14. So we're going to bring this up here and subtract it out. This is polynomial subtraction, so all these signs change. And as we bring our like terms together, we find that that goes to 0. That's what we like. This has terminated on its own, and we have that 7 is being added up here. So we find that when we take this polynomial and divide by this polynomial, we get a quotient of x plus 7. So another polynomial. This ended nicely with a 0 here, so we don't have to create any kind of a fraction up here. Take a look at these steps. And now try this challenge problem on your own. And then once you've worked through it, go ahead and continue the video, and I will work through it, and you can check your progress. All right. Looking at this, I want to rewrite it inside the division bracket. And then I'm going to create my ratio of first terms and multiply that by the number on the outside. And I'm going to subtract that from the number on the inside. And this is x up here. That's what I multiplied here. Now looking at these terms, I can do another ratio and divide. I'm going to take that and I'm going to subtract that over here, so all the signs are changing again. That ends in 0, so that's good. And we had -6 here. So the quotient we're looking for here is -6. Now I'd like to go back through and I want to do this problem again, only I want to use synthetic division. Synthetic division is something that works in a special case when you need to do division of polynomials. Beginning to look at synthetic division, we need to establish a few things. We're going to reuse this problem. We already know the solution, so this is going to be how we check ourselves. What we need to look for is that if the divisor, this number here, is of the form x minus c, which it is, it's x minus some constant number, then use the coefficients of all the terms of the dividend, which is this number over here, to create your synthetic bracket. So each of these p sub 1 through p sub n are however many terms that you have up here, and these are the coefficients. Now, this needs to be all terms of the dividend. This includes terms that you do not see. If you look through here, we have x squared, x to the first power, and x to the 0 power as terms. If this should skip one of those power terms, we have to add a 0 in as the coefficient. If this would have been x to the third, x to the first, and then x to the 0, where we skip the x2 term, we would have put a 0 in that position. Something that's slightly confusing here for students is that this c value here is not negative when we see x minus 4, because the c value itself, notice that this is x minus c, the c value itself is the 4, the negative is a part of the general form. If this had been x plus 4, the c value would have been the -4 with the negative that's already in the form here, is forcing that positive to be there. The double negatives are making positive. So this is what we're starting with as the idea, and our division bracket is kind of upside down compared to the last version that we did. Let's create this synthetic division. The C value is 4. It's going on the outside, and I create my bracket. My first coefficient is 1. My second coefficient is -10. And my third coefficient is 24. Inside the bracket is always addition. And outside the bracket coming around the side is always multiplication. We kind of always have a default 0 in here also with this first position. Starting inside the bracket, 1 plus nothing is 1. 4 times 1 is 4, so that's coming up here. So this is the cycle that we're using. -10 plus 4 is -6. -6 times 4 is -24. 24 minus 24 is 0. So I end up with this sequence here. Notice that when we built this, we eliminated all the x's. Now we have to put the x's back in, and we start with the power 1 less than we originally started with here in the dividend. So this was a quadratic, so the highest power was 2. So our result, our quotient, also called the depressed polynomial, will start with a power 1 less than this, so x to the first power. So this is the coefficient of x to the first power. This is the coefficient of x to the 0 power. So we have x minus 6 will be the result. And that is exactly what we got here when we did the long division. So we've done a division step here, synthetic division, that has gotten us the same result. So this, as you notice, seems to have less moving parts to think about. It's only addition and multiplication. It gets us the same result. It works when we have the key conditions that we need. So this is a nice way to divide. Let me give you one more example that's going to be a little more involved so you can see more of this play out. All right, this is going to be our initial problem. We have this cubic divided by this linear piece here. This is x plus 2. Does that fit the form that we need? Well, it does. If we just pull this over to the side and look at it, this is x minus -2. So the c portion is the -2. And we will use that, -2, outside the bracket. Our coefficient for the x cubed is 1. Notice that we have skipped here. We don't have an x squared. So the coefficient for x squared is going to be 0. The coefficient for x is 1. And then we have x to the 0 power is -8. So this is going to be our setup. Again, we are adding inside, multiplying on the outside. 1 plus 0 is 1. -2 times 1 is -2. 0 plus -2 is -2. -2 times -2 is a positive 4. 1 plus 4 is 5. 5 times -2 is -10. -8 plus -10 is -18. Now we need to reconstruct this into our depressed polynomial. We started with our highest power at x to the third. This will be x to the second power's coefficient. So we have x to the second power minus 2x to the first power plus 5x to the 0 power, and I have an extra number. this is going to be the remainder. It's our numerator, and the denominator is the number that we divided by. So this is the quotient that we get if we divide this polynomial by this polynomial. This is our quotient. Cheerful Calculations.